In this video, we're going to learn how to find the length of the radius of a circle given the center and a point that it passes through. So when I say a point that it passes through, I mean a point along the circumference of the circle itself. I'm going to show you two different methods that you can use to find the radius of the circle given a center and given a point that it passes through. So again, when I say a point it passes through, I mean if this is the center, this is a point that's on the circumference of the circle. So the first method is really nothing new. You've been doing this since the first unit of school, and that's just using the Pythagorean theorem. So if you were to connect these points, we would get a right triangle, and what you're looking for is the radius right here. So the distance from the center to the circumference of the circle we know is the radius. You can just sort of imagine what the circle might look like if we were to continue it. All right, so this is so easy to do with the Pythagorean theorem. We just need to look at the sides of the triangle. So it's 1, 2, 3, 4, 5 units this way, and 1, 2, 3, 4, 5, 6 units that way. So we're really just finding the hypotenuse of a triangle whose sides are 5 and 6, a right triangle that is. So using the Pythagorean theorem, we could do 5 squared plus 6 squared equals r squared. 5 squared is 25. 6 squared is 36. That's going to again have a sum of r squared. All right, so when I add those, let's see, 36 plus 5 is 41, 51, 61. So we should get 61 when we add to get r squared. And then finally, to find the radius, we just take the square root of both sides. So we get the square root of 61 is equal to r, the radius. And we could leave that as a square root, like we could leave that as a radical, or we could plug that into our calculator and approximate that as a decimal. I'm okay with us leaving it as a radical for this example. In our second example, we're doing the exact same problem. So we already know the answer. We already know it's the square root of 61. But I'm going to show you a different method using the equation of a circle. And I like this method better, but you can use whichever method works for you. So we know that the equation of a circle can be written as x minus h in parentheses squared plus y minus k in parentheses squared equals the radius squared. And we know that the point h comma k is the center of the circle. So when we look at our center in the problem, we're given h and k, and we're also given an x and a y value. So we could just plug those into our equation and leave the variable r, or r squared rather, by itself. We could simplify this entire side of the equation and it should be equal to r squared. All right, so let's do that. So I'm going to even start out with, you could probably do this in one step, but I'm going to start by saying x minus negative 4, which is the same as x plus 4 squared, plus y minus 7 squared equals r squared. And again, I'm getting that 4 and 7 from the center. And again, that's a positive 4 because that's a negative. And then when we have y minus 7, that's a positive 7 for the y coordinate of our center. All right, so now we're given an x and y value in the point it passes through. Every point on the circumference, we should be able to plug in for x and y, and the equation should still be true. So now I'm going to say when x is, oops, wrong tool there. When x is negative 10, this is negative 10 plus 4 in parentheses squared. And then over here for y, we said y is 2, so 2 minus 7 in parentheses squared equals r squared. So now when we combine our like terms in the parentheses, or just simplify the parentheses, we get negative 6 squared plus negative 5 squared. Boomer, shh, sorry, that's my cat. And that equals r squared. All right, so if we just square these, that's going to be 36, because remember, negative 6 squared is positive 36, plus 25, all of that equals r squared. And we still get 61 is r squared. So the square root of 61 is equal to r. So I don't really care what method you use. You can do the Pythagorean theorem. I think I like this method because it gives us the opportunity to use our new learning, which is the equation of a circle. But you can use whichever. You just might not always have access to graph paper. So if you can do the Pythagorean theorem one, make sure you can do that one without using the graph, or without relying on the graph, I should say. All right, that's it.